Today's topic in electrochemistry is batteries or cells. So what are these batteries or cells? In these batteries, the energy released during a chemical reaction is converted into electrical energy. In our daily life, we have observed a number of cells or batteries like pencils for the purpose of clocks, laptops, etc. and etc. There are two types of batteries, primary batteries and secondary batteries. Primary batteries, they cannot be recharged once after their use, whereas the secondary batteries can be recharged after their use. We know our cell phone batteries, they can be recharged after their use. Similarly, inverter batteries, they are also called lead storage batteries, they can be recharged after their use. But pen cells, small batteries, or batteries in the watches, they cannot be recharged after their use. The pen cell or a dry cell is a modification of Leck launch cell, or Leck launch cell is a zinc MnO2 cell. Its modification is a primary battery, that is a dry cell. Okay. In a dry cell, it appears like this. This is we use this cell in a daily life. It is called pen cell. It consists of a zinc plate which is molded into a tube. At the center, a graphite or carbon rod is placed, and the gap is filled with a mixture of MnO2 and ammonium chloride placed. Here, the zinc plate, it acts as anode. It means Zn, it becomes Zn plus 2 electrons. This is an anode reaction. Whereas a MnO2 plus NH4 plus present around the graphite rod acts as cathode. The reaction is Mn2O3 plus 2NH3 plus H2. This is a cathode reaction. The overall reaction will be like this: Zn plus 2 MnO2 plus 2 NH4 plus, electrons are cancelled, Zn plus 2 plus Mn2O3 plus 2 NH3 plus H2. So here NH3 formed, it will not escape out, it is a gas. It immediately combines with Zn plus 2 and forms a complex. As long as the Zn is present on this plate and MnO2 is present in the mixer, it works continuously. Once these chemicals are completely reacted, the cell will not work anymore. So that is the reactions of dry cell. It is a primary cell which cannot be recharged after its discharge. What are secondary batteries? The batteries which can be recharged after their use are called secondary batteries. The examples are lead accumulator, that is inverter battery, or very simply our cell phone battery that can be recharged after its use. Lead accumulator or inverter battery, it consists of a very big tank made up of plastic in which alternately arranged lead plates, insulation with thermocol and lead dioxide plates. Like this, lead and lead dioxide plates are alternately arranged. And the electrolyte is sulfuric acid. While discharging, the reaction is Pb plus PbO2 plus 2H2SO4 discharging 2PbSO4 plus 2H2. Here the reaction is reversible. The forward reaction, the current present in the lead accumulator or lead storage battery comes out. During charging, the reverse reaction takes place. Charging. What are anode and cathode? In this lead accumulator or secondary cell? Observe here Pb. It is converted into PbSO4. I mean Pb plus 2. Pb, it gives rise to Pb plus 2 electrons. During discharging lead electrode, it acts as anode. Here PbO2, Pb in plus 4 oxidation state, again it is converted into plus 2. PbO2 again it is converted into Pb plus 2. Pb in plus 4 takes 2 electrons and becomes Pb plus 2. So this is cathode reaction. Pb is converted into Pb plus 2 by the loss of 2 electrons. Pb in plus 4 is converted into Pb plus 2 by the gain of 2 electrons. During discharging, lead is anode and lead dioxide is cathode. The overall reaction will be like this. Pb plus 4, it gives rise to 2Pb plus 2. So anode is lead, PbO2 is lead dioxide. During charging, Pb plus 2 is converted into Pb by gaining of electrons. This is a discharging process. During charging, Pb plus 2 is converted into Pb and Pb plus 2 is converted into PbO2 or Pb plus 4. During charging, Pb plus 2 takes 2 electrons and it is converted into Pb. Pb plus 2 loses 2 electrons and becomes Pb plus 4. During charging, the reaction takes place. A single oxidation state changes into 2 different oxidation states. The reaction is called disproportionation. That is, the backward reaction is a disproportionation, while the forward reaction is a comproportionation. Another secondary battery generally used in cell phones is nickel cadmium cell. Nickel cadmium cell, it can consist of very thin papers of nickel 3 hydroxide and very thin papers of cadmium. And these 2 papers are separated by an insulator like thermocol paper or something like that. In this cadmium, it acts as a anode. It combines with the OH minus, CdOH twice plus 2 electrons. A thin papers of cadmium act as anode. nickel 3 hydroxide, NiOOH. It takes electrons plus H2O. NiOH thrice NiOH twice plus OH minus. So multiplying this equation with the 2. You can cancel 2 electrons, 2 electrons, 2 OH minus, 2 OH minus. What is the overall reaction? CD plus 2 NiOOH plus H2O. It gives rise to CdOH twice plus 2 NiOH twice. This reaction takes place while discharging, and the backward reaction is charging. NiOOH, nickel 3 hydroxide, it is cathode, which is converted into Ni2OH. So this is a nickel cadmium cell, of course expensive, hence it is used in cell phones. Another important cells are fuel cells. Fuel cells means fuels are chemical substances which burn in air or oxygen and produces large excess of heat. The heat energy is converted into electrical energy. The best example is a hydrogen oxygen fuel cell. This hydrogen and oxygen fuel cell consists of 2 porous graphite rods which acts as electrodes placed in an alkali solution. Here hydrogen H2 plus OH minus, 2 H2O plus 2 electron, it acts as anode. Two H2O plus O2 plus 4 electrons, it gives a 4 OH minus cathode. So hydrogen electrode acts as anode and oxygen electrode acts as cathode. Multiply this equation with 2 so that we can cancel electrons and OH minus. The overall reaction is a 2H2O plus O2, it gives 2H2O. This is the overall reaction. What is the importance of fuel cells? Fuel cells are works silently, and fuel cells are highly efficient, and the most importance of fuel cells is they are non-polluting. There is no chemical which pollutes the environment because the byproduct is only water. Whereas in case of other cells, some lead compounds which pollute environment and water, and some other chemicals like cadmium hydroxide, nickel hydroxide, zinc compounds, etc. But in the fuel cells, the advantage is non-polluting. But only disadvantage with fuel cells is to carry hydrogen is very, very difficult.